Unit 20, Gateway. Radioactive waste disposal has become one of the key environmental battlegrounds over which the future of nuclear power has been fought. Environmentalists argue that no system of waste disposal can be absolutely safe, either now or in the future. Governments and the nuclear industry have tried to find acceptable solutions. But in countries where popular opinion is taken into consideration, no mutually acceptable solution has been found. As a result, most spent fuel has been stored in the nuclear power plants where it was produced. This is now causing its own problems, as storage ponds designed to store a few years' waste become filled or overflowing. One avenue that has been explored is the reprocessing of spent fuel to remove the active ingredients. Some of the recovered material can be recycled as fuel. The remainder must be stored safely until it has become inactive. But reprocessing has proved expensive and can exacerbate the problem of disposal rather than assisting it. As a result, it too appears publicly unacceptable. Exercise 1. There are some renewable energy technologies that are only controversially considered alternative, and they include nuclear power and hydropower. Both nuclear power and hydropower are emission-free, and so alleviate the most common negative consequence of fossil fuel-based energy production, air pollution. However, they suffer from other environmental problems that make them unattractive to some advocates of alternative energy solutions. Nuclear power produces highly radioactive wastes that must be stored and safely disposed of for long periods of time, and hydroelectric power traditionally comes from large dams that block free-flowing rivers and disturb natural riverine ecosystems. Newer forms of smaller run-of-river hydroelectric plants avoid the negative consequences of large dams and reservoirs, but their potential physical implementation is limited, and so they will never serve as the predominant solution to worldwide energy needs. Nuclear power and hydropower, therefore, as with most alternative energy sources, solve some problems but not others. Exercise 2. Repurposed clothing tells an even more complex tale than that of second-hand garments. Until recently, clothes that were extensively altered from their original form were frequently overlooked in museum collections, as it was believed that their alterations rendered them inauthentic. Today, however, analyses of such objects by scholars like Alexandra Palmer, fashion curator at the Royal Ontario Museum, Toronto, as well as the embrace of repurposing techniques by high-end fashion labels, have imbued altered objects with newfound significance. Such clothing is now used to provide insight on the high value placed on textiles in the past, as well as to how that value has diminished over time. In the past, second-hand or recycled cloth goods were typically utilized for markedly different reasons, such as thrift, economic necessity, and appreciation for well-made materials. Examining remade garments also highlights a resourcefulness and skill that is all but lost in the contemporary fashion industry. In many ways, these garments acted as early models of sustainability. Exercise 3. Kids and adults around the world are coming up with creative ways to use less fuel. For example, in the slums of Manila, Philippines, people live in tiny shacks made from sheets of metal. Until recently, the shacks were completely dark inside. Anyone who was too old or sick to go outside had to spend every day in darkness. But one day, Ilac Diaz, who is part of an organization called My Shelter Foundation, looked at an empty pop bottle and had an idea. Soon, all around the slum, People were cutting small bottle-sized holes into the roofs, inserting a pop bottle with a few teaspoons of bleach inside to keep dangerous molds from growing, and gluing the bottle into the roof. Suddenly, light poured down into places where people had never had light before. Exercise 4. Within the arena of household consumption, research predominantly focuses on direct rebound effects among consumers, particularly for energy appliances in the home and fuel efficiency in vehicles. For example, often large energy savings are predicted when consumers replace traditional incandescent light bulbs with more efficient compact fluorescent bulbs. However, these savings rarely reach their predicted targets, as research indicates that many consumers, recognizing that the light costs less to operate, appear less thorough about switching it off, resulting in more hours of use, i.e., higher energy consumption. Similarly, studies have indicated that energy savings from efficiency improvements, for example, a more efficient space heating unit or increased levels of insulation, are often then spent on increased heating standards. Here, the consumer may gain by operating a warmer home for the same or lower cost than they had previously.